Welcome again back to Cosmic Careers Podcast with Alistair Brown along with Veronica Chiaravalli.
Hello, everybody.
Today is Chapter 10 of Cosmic Careers called Settling Mars. Next week will be the final podcast with the conclusion, and then we freely discuss talking about the possibilities of new jobs that will be available for all skills. We will now talk about settling on the Red Planet.
What many people don't realize is that it's going to be a lot harder than you think. There are many, many obstacles that the public knows very little.
Many of these obstacles are distance, temperatures, and weather and radiation. The distance between Earth and Mars and the time it takes to get there is also a factor in the problem of radiation, as we shall see.
First, we'll cover the distance.
The distance from Earth to Mars ranges from 34.8 million miles, or 56 million kilometers at the closest point to Earth, to 250 million miles, or 400 million kilometers at the farthest point from Earth, depending on their positions of orbit around the Sun. At the shorter distance between the two planets, the launch window occurs every 2 years and 2 months. Regular supply runs like food and medical care will be almost impossible. Should an emergency come up, the travelers, once they leave the Earth's neighborhood, will be completely on their own. If they need a doctor, he will have to be a part of the crew.
People often ask, why should we go to Mars?
The answer is, arguably, that it is the most like Earth and may have been like Earth at one time. It is believed, and evidence points to it, that Mars once held a thick atmosphere. It also had lakes, rivers, and an ocean in the northern hemisphere. There are deep formations and canyons in the patterns of lakes and rivers, and the northern hemisphere is 2 to 3 miles below that of the rest of Mars. And there is water in the form of ice beneath the ground and at polar ice caps, covered by a small layer of carbon dioxide.
Today, Mars is a frozen planet with a very thin atmosphere covered with red sand and rock formations. There was a cataclysmic change in climate, and we want to know how that occurred.
Another reason why we want to venture there is to see if there is or ever was life. It has been theorized that Mars may have once contained life, or still has some form of life underground. The existence of water backs this up, although it is still mostly ice. NASA does send probes to investigate these matters, with the first 2 probes in 1976, the Viking landers, experimenting with the soil searching for life. They haven't succeeded in finding any, but there are those who are not satisfied with the results. They want to know more.
Subsequent probes have been sent to explore the Martian surface and send back pictures of formations of the landscape. Many are robotic probes moving around the surface to do this task, like Spirit and Opportunity. There are proposals to send crewed expeditions to Mars.
The chief one is Mars Direct by Robert Zubrin. He is set on settling on Mars as a new world for humans. Zubrin proposed to send crews to Mars every 2 years with separate supply vehicles and return ships sent in advance. Mars One, a proposal by Bas Lansdorp, wanted to do something similar to Zubrin, but Lansdorp proposed a one-way trip to Mars where people would be sent to spend the rest of their lives there. There would be an original crew of 4 sent, and every 2 years another crew of 4 would be sent with proper materials and survival gear to develop the surface, where, as more people are sent, the settlement would grow into a town in a slow manner. People would be born there, being the first Martians. Unfortunately, the Mars One project lacked the funding and soon declared bankruptcy.
Elon Musk, founder of Tesla and SpaceX, probably has the biggest plans for Mars of all. Elon Musk's Starship, designed for heavy cargo and moon travel, eventually wants to use it to go to Mars.
His plan is to load up astronauts, launch it into Earth orbit, use another rocket launched afterward as a tanker for refueling, and then travel to Mars. The craft would travel at 100,800 kilometers per hour, or 62,634 miles per hour, with solar arrays providing power for the journey. As they approach Mars, the ship would enter the atmosphere, landing gear would be deployed, the ship would land, and the astronauts would then get out and walk upon the Martian surface. As more missions progress and settlements are set up, cities would be built, and Mars would eventually be terraformed.
NASA has its own plans using the Space Launch System. With a Boeing rocket and an Orion capsule, journey to Mars, rendezvous with landers already placed in Martian orbit that were sent ahead of the crew, go into one of them while the other landers carries supplies for these astronauts. And when they both land, set up a base camp.
These are all good plans, but which one would be used? We don't know. Perhaps something completely different. I feel it's not yet time for Mars until we have already set up an Earth to Moon infrastructure with space and lunar settlements and industry. But that's my opinion. Private expeditions to Mars may occur as we set up a cislunar infrastructure. These expeditions may be privately sponsored with little or no fanfare. Subsequent expeditions may occur and they may set up small settlements with the necessities to survive. Again, this is just my guess.
There is one big obstacle to Mars, and that will be the most dangerous of them all, radiation. This will be dangerous traveling to Mars, and it will be dangerous settling on Mars.
There are three types of radiation up there: solar wind, solar particles, and galactic cosmic radiation, the most dangerous of them all. The Earth itself is protected from radiation by its magnetic field, called the magnetosphere. I'll set up a pattern. On the Earth, we are exposed to only 0.1% of cosmic radiation. On the International Space Station, exposure is up to 100 to 150 times greater than Earth, meaning 10 to 15% of cosmic radiation. On the Moon, it's 300 to 400 times greater than Earth, 30 to 40% of cosmic radiation. This is why we need radiation shielding up there. Here is where Mars comes in. Traveling to Mars in a spaceship would, at times, deliver about 1,000 times more radiation than on Earth. That's 100% of cosmic radiation. On the surface of Mars, the exposure would be 2.5 times greater than that of the ISS. That's 250 to 375 times of Earth. So the biggest threat would be traveling from Earth to Mars. In dealing with all this radiation, solar wind could be deflected by the spaceship's skin. Solar particles, meaning high energy particles and possibly solar flares, can be deadly, but the astronauts would have advanced warning and they could go to a protected part of the ship. It's the galactic cosmic rays that are the real danger, and there is no efficient shield to protect the astronauts anywhere in the ship. The danger here is that the energetic particles could knock atoms apart in any material they strike, from a spaceship to a human being, resulting in sickness or death for the human. So, in order for the ship to escape cosmic radiation altogether, it would have to be a very high-speed space vehicle, like being able to go to Mars in 2 weeks or a month rather than the predicted 9 months.
There are ways to deal with this problem on a ship.
Creating mold 21 centimeters thick has been found to be radiation resistant. Certain drugs have also been found to aid in treating radiation. The third, which hasn't been tried, is hibernation. If we observe bears and how they hibernate during the winter months and imitate them, and this is where the job of bear biologist comes in, some astronauts could go into hibernation, slow their metabolism, thereby making their bodies more resistant to radiation, combined with drugs and radiation shielding for the ship. All this could protect them, along with traveling in an ultra high-speed spacecraft.
The problem, however, would not end with landing on Mars. Mars itself has a serious radiation problem coming from space as well.
Mars has no magnetic field. This is because the Martian cores, both its inner and outer cores, have cooled down over the millennia, causing it to lose its magnetic field and its ocean. When the cores were hotter, a magnetic field was generated by the activity of the liquid iron in the core, but it cooled down rapidly due to the size of the planet. The inner core, which is still partially liquid, lost its function and everything disappeared. Mars now has no protection against the cosmic radiation. The radiation on the Martian surface is less than that of space, but it is still lethal, so any human on Mars will need protection against radiation, like on the Moon. There is the technology of radiation shielding I have previously described on the Moon and in O'Neill space colonies. Set up habitats on Mars and cover them with regolith or build them underground would be one way of dealing with the radiation problem.
We can take lunar glass and build a dome and set up settlements and farms and later cities.
One proposal I have seen at a space development conference, and this is not in the book, is to build a house made of ice. Ice and water also provide protection from radiation. The process is to use a 3D printer, take ice from a nearby source, convert it to water, and then, with the use of a printer, use the reconverted ice to form a circular shelter, say 100 meters high, and outside of that structure for another layer surrounding it with a gap between the two structures. Plant life can be installed in this gap, along with the stairwell to different levels of the ice structure. The ice would never melt, not even during the summer because of the Martian temperature. The place can then be furnished, heated, and attached to water and power sources and have a comfortable dwelling with a transparent view of the outside surface of Mars and fully protected from radiation. The plants would provide both oxygen and food.
Like the Moon, building a settlement on Mars will require all kinds of professionals: doctors, geologists, chemists, agriculturalists, builders, machine operators, radiologists, and many other professions I can't even imagine right now, but they will still be needed.
As we overcome these obstacles of low temperature, a thin atmosphere, and radiation, we will want to make Mars more like Earth, a process known as terraforming. We will want to make it warmer, thicken the air where you can breathe without a spacesuit, and with little or no radiation hitting the Martian surface.
This has been the theme of many science fiction writers and space advocates. The drawback is that it could take hundreds or even thousands of years. We want to hasten this process. Is this possible?
Maybe. We could begin to heat up the atmosphere, perhaps with a mirror in space to focus the sun rays on the planets, melting the polar ice caps. This in turn would supply water and thicken the atmosphere with carbon dioxide. CO2 is a cause of climate change on Earth, but on Mars it would be very beneficial. Introduce plant life to convert the CO2 to oxygen for us to breathe. With an ocean in the northern hemisphere and a forest covering the planet, Mars could come to resemble Canada. Deposit animal life forms and other species to create an ecosystem. Nurture an ozone layer to protect the planet from radiation. Ozone is easy to make. You do it each time you drive your car. Sustain the emergence of liquid water on the planet. Deposit life in the Northern Ocean. There would also be rivers and lakes a plentiful water supply? Maybe it is, maybe it isn't. If it is, could we do it within 100 years rather than 1,000 years? Again, maybe it's possible, depending on how determined we are. We can only wait and see.
Next week will be our final podcast for Cosmic Careers.
Yes, and we will briefly cover the conclusion, and then Veronica and myself will freely discuss the appendix. This is a partial listing of possible jobs in the space movement, whether it be in space or on Earth. We will cover a wide variety of skills you would never think would apply to space, but they could. More on that next week. Of course, all of this is in Cosmic Careers. Don't forget to order your copy on the net or in your local bookstore. Thank you, Veronica. Thank you, the listener, and goodbye until next week.
Goodbye, everybody.